Hello, and welcome to the Trepa Technologies Security Plus course. My name is Johnny Bandon, and I'll be your instructor for this video series. This video will cover Domain 3.8, Authentication and Authorization. Now let's get started. As security administrators, we manage, direct, and advise authentication and authorization in our enterprise. There are many different technical implementations of authentication and authorization we must understand for our enterprise to be secure. Password keys are security devices that are used for two-factor authentication. Password keys can come in different form factors, like a USB or USB-C device. An example of a commonly used password key is the Yubico USB key, a simple solution for two-factor authentication. Password vaults are software password managers that store all your passwords. In enterprise security, administrators can use password vaults to store all the sensitive passwords the IT department may use. For personal use, you can use a password vault to store the dozens of different passwords you may use for all your online credentials. In personal use, I use a password vault called KeePass, which is an offline solution. Knowledge-based authentication is used to strengthen accounts and password recovery processes. These are often encountered as security questions that only the user may know. These knowledge-based questions can be helpful for password recovery. Still, with the prevalence of social media, these knowledge-based questions can now be answered through some simple research into a person. The Challenge Handshake Authentication Protocol, or CHAP, uses a three-way handshake to send authorized credentials across the wire between systems. This standard protocol was used in site-to-site network connections, but has since been replaced by more robust authentication frameworks like EAP. Single sign-on allows users to use a single account to access many different services. SSO was made possible using federation and different identity providers to provide identity authentication and authorization. Oh, excuse me, didn't know I had my KeyPass still up there. And now let's get into some federation protocols. So OAuth is an open standard for access delegation. It allows users to determine what information they share with a third party, like when you have to allow access on your phone for specific applications. OpenID is a standard that websites rely on to have third-party IDPs authenticate users. So when you sign into a website using Google credentials, you are using OpenID to authenticate to an identity provider that will give you access to the original website you were trying to access. In the case of OpenID, the user will make a request to the relying party, which is the site they're trying to access. The relying party will then send that request send that request to the identity provider. And the identity provider will then authenticate the user against their authentication servers. Once they have authenticated the user, they will relay that information back to the relying party. And once the relying party acknowledges the IDP or identity provider, the user is now granted access to the relying party's website or application. SAML is another federation service or protocol that uses identity providers to authenticate users. In SAML, the service provider and identity provider must establish a trust connection. The user will then authenticate against the identity provider to access the service provider's resources and networks. So OpenID is going to be the most common one we see nowadays being used. If you log into a site using Google, Facebook, or Twitter, or Amazon, whatever it may be, more than likely you're using OpenID as the protocol or the federation service, right? Because these are all federation protocols or services. Radius is an authentication, authorization, and counting protocol used for NAC, network access control. Radius is an open standard protocol commonly used in wireless networks for authentications. Radius will not encrypt the entire payload, and it will only encrypt the password in a Radius packet. In Radius, endpoints or user devices are supplicants that will provide login info to a Radius server, which will then pass on that supplicant's information to a AAA server to authenticate and authorize the supplicant, which would be our client devices. TACX is a AAA protocol similar to Radius, but it is Cisco proprietary, and it'll use TCP for connections instead of UDP, which is what Radius uses, and it'll actually encrypt the entire payload, where Radius will only encrypt the password. Kerberos is a secure SSO protocol that uses ticket grading tickets to authenticate to a Kerberos resource on the domain. It is important to note that Kerberos is used internally on the enterprise and requires that the times be synchronized on the key distribution center so that the tickets can be granted to the network resource. Now, Kerberos is another one of those protocols that you can really deep dive into to learn how it works because there's a lot of steps in it, right? Using these ticket granting tickets, having a key distribution center, giving access to a client on the network to other network resources, right? So if you want to deep dive into Kerberos a little bit more, stay tuned for our bonus videos where I'll try to demonstrate how Kerberos works in real time, right? Try to do a Wireshark capture and go through the 6 steps. If you look at our diagram here, it'll also tell you how Kerberos works. So client requests a ticket granting ticket. That's to the key distribution center. The KDC verifies the credentials and sends back an encrypted ticket granting ticket to the user. The client then sends the ticket granting ticket to the ticket granting service and requests a service ticket. So back to the KDC. That service ticket sent back down to the client. And then the ST, that service ticket, is sent to the server hosting data, which this could just be like a file share, right? Or a file server. And the client is able to access that service. So this kind of just gives you like the bluff, right? Which stands for the bottom line up front of how Kerberos works. Now let's get into some access control schemes. So as security administrators, we must also understand the different access control schemes we can implement in our environments. Mandatory access control is considered the most secure way of controlling access to data. In the MAC scheme, a user must have a certain clearance level to access data. Data must also be classified appropriately and put on segmented networks that reflect that data sensitivity. Take, for example, the DoD's MAC scheme. The DoD, or really the government, has separate networks, entire networks for unclassified, secret, and top secret data. And if a user does not have a top secret clearance or a need to know, that user will not be granted access to this top secret network. That user will not be allowed to have any user account on a network other than unclassed or maybe secret if they have a secret clearance. MAC is a very tedious control because it takes a whole section or department to even verify a user's clearance level and then to be given access to a whole network like a secret network. So there's a lot of moving pieces in it and a lot of administration. So IT guys that work in the government have to work on 3 or 4, sometimes 5 different networks. That means 5 different user accounts, 5 different admin accounts, 5 different implementations of Active Directory. And the list can go on, right? So it's very tedious work, mandatory access control. Discretionary access control is the default access control used by Windows. In discretionary access control, the owner of the data determines who is granted access. For example, when you create a folder on your desktop and you want to share that folder with others, so you right click, settings, share, right? And then you come to this screen where you determine who's going to get access to that shared folder. That's because you're the owner and that is discretionary access control. And then we have role-based access control. Role-based access control resources are controlled by what an individual's responsibilities are or their job role. So, for example, suppose an administrator is hired for database development or they're a database engineer. In that case, they will be given access to the database servers, but they will not need access to the Exchange servers because that is not a part of their role as a database administrator. So, think of role based access control as a way to give people exactly what they need. Rules based access control, these rules are set by the administrator An example of this is configuring when a user can log in or configuring only specific systems that the user can log into. And then attribute access control is the more granular level of access that combines rule-based and access-based controls and file attributes to determine access, right? So this can just use specific attributes to give someone access to something. So this could be their policies, their location, their environment, right? And then an important thing to note when it comes to all these access controls, all these access control methods can be used simultaneously on the network. And most enterprises will implement most of these on their enterprise, depending on what access permissions need to be set and how big your enterprise is. I know in the government, we typically will use all these. The only one that maybe might get scratched is discretionary access control, just depending, right? But typically, environments will see these different access controls being used for different scenarios. All right, and then we have Privileged Access Management, or PAM. This is a software tool that will maintain and alert access control policies on our enterprise. So PAM tools ensure that least privilege is maintained by providing granular controls and actually giving reporting and alerting and audit capabilities. And then file system permissions are a standard access control scheme where file system permissions group permissions by owners, group, and everyone else. In file system permissions, you can determine what level of access and control a group or individual can have on a specific file. And then the last thing we'll go over is actual file permissions and how they're set up with the read, write, and execute. So file permissions can be very granular and determine what a user can do to a file or data. A user or group will either get write, read, or execute access to a file. Users, groups, and owners can have any combination of file permissions. Take, for example, in Linux, file permissions can be expressed with numbers or letters. The number is binary and will equal 7 when added up all together. That is the read, write, and execute permissions. So something like this, right? 421 be read, write, execute. And when you get that full 7, you'll have full permissions to read, write, and execute permissions. And then they also have this in a letter representation, where full permissions will be expressed with the lowercase RWX. So if you go over this right here, this section right here will determine if it's a directory or file. It'll show you whether or not a user, what level of access, so this is full. If a group will have this level of access, and everyone else, right, the world, will have this level of access. And then this chart gives you a nice little explanation. So if there's a 1, they have execute permissions. If there's a 3, they get execute and write permissions. If there's a 7, they get read, write, and execute. If you look at this in binary, right, if we were to give it a 3, that's 1 and 2 combined. If we were to give it a 5, that's taking away the 2 and just using 4 and 1, so they just get read and execute. So that's kind of how these file permissions work. And then in Linux, chmod is the command we'll use in the command line to actually change these file permissions. All right, that will wrap up this video on authentication and authorization. Stay tuned for our last video in Domain 3.0, where we will go over the public key infrastructure. Thank you for viewing.